and come up with a conclusion. So I need to connect this. So when we're starting a proof, who can tell me what is always the first thing that we are going to put into our proofs? What did you need, Tucker? Oh, I walked right by you and you like kind of shoved me off. Too distracted. Too distracted eating your Doritos, I guess. Huh?
It's too good.
So when we're starting to construct our proof, what's always the very first thing that we're going to do for our statements and reason? Given. So we go up, we find out what is given to us, and yes, we do need to rewrite that out. So I know that it seems redundant, but that given is up there. We got to start our logical argument and say, hey, this is what's given to us. Now I'm going to start to use this plus anything else that I know to continue to prove my two triangles are congruent. So number one, we start with angle D is congruent to angle G. And secondly, we're going to say E is the midpoint, and I'm going to kind of abbreviate this. E is midpoint of my line or segment HF. So there's my two pieces of given information. And reason is only given. So every time we start a proof, we're going to start with our given. Our reason is going to be given, and then we're going to kind of start on our way. After I've done the given, I'm going to kind of take a peek and look at, okay, D and G are marked, and I'm going to keep track of that. And then I got E as the midpoint of HF. Now, I don't necessarily like this. This diagram actually puts the congruent symbols. We still are going to say that these two segments are equal because of the definition of the midpoint. So definition of midpoint says that the segments are congruent because the midpoint always splits a segment into two equal pieces. We'll get to that in just a second. But you're going to want to take a peek over at your diagram and start to mark those given things because your goal is you're trying to get three things congruent between the two triangles in one of the patterns that can prove triangles congruent, which is SSS, SAS, ASA, or AAS. Those are the four that we're going to use. So we're proving the triangle is congruent. Awesome. Moving on to step two. Number two, what I like to do, and kind of the proof process sheet that we posted in your Schoology, is look for the things you can tell without markings, which are vertical angles or reflexive properties. So you're looking for, is there an X formation where we have two angles opposite that we can prove congruent? Because if we have that X formation, we can prove that angles are congruent without any markings. There doesn't have to be somebody telling me, hey, these are vertical angles. If I see vertical angles, I can prove that they are congruent. Same with the reflexive property. If we see any overlapping pieces, so like two sides of a triangle are overlapping, or two angles are overlapping, which we'll see as we get into more proofs later on in the chapter. We're going to prove using the reflexive property or vertical angles. Those are two things you can tell without markings. So I'm going to go ahead and do the vertical angles. Angle HED, which is this angle. Now, since I named it HED, I'm looking up at this congruent statement. I went from H to E to D. So I went middle, first, last. It's going to be congruent to FEG. So I went middle, first, last. So I can use that congruent statement to organize how I name those angles, because I have to name them to show that they're congruent with the same order of those letters. So I'm going to go FEG. I'm sorry I'm getting a little crunched, but there would be angle FEG right there. When we're done. Are y'all done with this already?
Yeah.
Oh, okay. Well, you can get some extra practice, then you can go. Number two, we've got angle HED is congruent to FEG. Now, the reasoning is vertical angles. So there's what I can prove without having to have any markings. I can say those two angles are congruent. Now, I know I do have these markings here, but since the midpoint splits HF, I still need to use definition of midpoint to say that HE is congruent to FE. And that's going to be my definition of midpoint. So we have a lot of things happening now. I'm going to check. I do have 3. So I've got a set of angles here. I've got a set of angles here, which I should be marking with 2 arcs to show that they're different than the other 2. But anyway, I've got a set of angles here, and then I've got a side. So I've got an angle, and a side. Now I look at the pattern. So if I start with this angle G right here, this is going angle, angle, side. This one is going angle, angle, side. So do I have enough to prove? Yes, using angle, angle, side. So I'm going to rewrite my congruent statement. I'm just taking where it says prove there. Triangle EFG is congruent to triangle EHD. And the reasoning is, number 4 is AAS. So there's going to be my 2 triangles proven congruent. So we have those different patterns, SAS, SSS. You're working through your proof. You're trying to find 3 parts, and then you're just making sure that they're in one of those patterns that we can use. The only one you can't use is ASS. And it's pretty easy to remember is because it's not a good word. So ASS is the only one that you can't do. It's the only pattern that doesn't work. Yeah, sound it out. Sound it out. Maybe I'll figure it out. ASS. Can't use that one, but otherwise you can use those other patterns. So there's our proof. Now on the quiz, this is a 4-point question. You get 1 point for your reason of given, 1 point for vertical angles, 1 point for definition of midpoint, and then 1 point for the AAS. So that's 4 total points. Am I okay to erase this one? Okay. Heading to 14. On to 14. Here we go. Number 1, we're going to put our given. So number 1, we're going to have JM bisects angle J. And number 1 also, we're going to have JM is perpendicular to KL. So there's going to be our given information. The order your steps go doesn't technically matter. When we do our reasons on the fill in the blank proof, it'll matter which reason you put with each step. But for the second one, I always like to just do the one we can tell without marking. So you look at your 2 triangles. You've got a triangle on top, triangle on bottom. Kind of a bigger overall triangle. But you're looking between these 2 triangles. Is there any sides that are overlapping? Or are there any angles that are in an X formation? So what are we seeing? Do you see any sides overlapping or angles that are in an X formation? Do you see sides overlapping?
Yeah.
Yes. Which 2 sides overlap? JM, JM. So we're going to start by saying JM is congruent to JM because of the reflexives. That's the other one we can tell. We don't need to have anybody tell us that those 2 are equal. If they're the exact same, in each triangle, they're going to be congruent to each other. So now that counts as one side that's congruent between the 2 triangles. The JM on the one triangle is going to be congruent to the JM on the other triangle. So we've got an S so far. How many more things do we need to prove? 2 more yet. We got to get 3. We got to get 3 different things that are going to be congruent. Next, we can look at that first part of the given. JM bisects angle J. So right here is angle J. So angle J is this full angle going to the L, going to the K. This JM is going to bisect, which makes these 2 angles congruent. So bisect is going to split an angle into 2 equal angles. So we'll use KJM. So we'll say angle KJM is congruent to. I looked at how I put that. I went from K, last, first, middle, KJM. I'm going to go last, LJM. So I'm going to use the same order. So I get my letters all to match up. And that's going to be definition of bisector. So a bisector splits an angle into equal parts. A midpoint splits a segment into two equal parts. So we use definition of bisector, definition of midpoint. That's going to be another way we can prove two things are congruent. Now lastly, we get that JM and KL are perpendicular. So if you have two lines that are perpendicular, they make special angles. What type of angles do perpendiculars make? Out of twos. What does this box stand for? Right. They're going to make 90-degree angles. So we're going to lastly say for number 4, this will be our third part congruent, then we'll kind of reevaluate. JMK is congruent to JML. And the reasoning here is all 90 degrees are congruent. Sometimes we'll say all right angles are congruent, whatever the case is, all 90s are congruent. We don't need to do anything else there. We know that if we have two lines that are meeting at perpendiculars, we're going to get 4 congruent angles basically if you extend out those lines. And now we check, we've got 3 things. Is that enough? Well, we've got an angle, a side, an angle, 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 side, angle. So is that one of our 4 that we could use? You bet. So number 5, I'm going to rewrite the congruent statement. JMK is congruent to JML. And number 5 is going to be because of angle, side. So there, you had 5 total steps. How many points is this proof worth on a quiz or test? We have 5 total points that it'll be worth as well. So last thing we'll do is we'll take a look at a little practice problem on the quiz. So you can kind of just see how the quiz is set up. So you can see your reasoning side, you can see your statement side, and you can kind of do your matching fill in the blank type answers. But before we do that, I need to check with you. Is it okay if I delete this problem? You guys got your proofs finished? Excellent. All right, so then we'll head into yep, that's up here. Take a look at that practice problem. Okay. So I'm guessing you guys have it pretty much under wraps here, but here, so we've got our given, we've got our proof. Sorry, it's kind of small, but here's our given, and then that given is repeated here, so I'd put in given for my first answer. Okay, so we're just matching up. What is this? Statement, reason, combination. AD is congruent to AD, so here we have those overlapping pieces. What property says that the overlapping pieces are congruent? Reflexive property, so I'll use that next. I know these are kind of small for you to see down there. Now, the only unfortunate thing is now we don't have the markings that we can do, but if you want to, you can just sketch this out on a piece of paper, mark, so you get 3 things, and then make sure those 3 things are in one of these orders. But so far, we've got a segment right here that's congruent, and then we've got AB is congruent to AC, so we've got another side up here that is congruent. Now, AD bisects BAC. So here we have BAD is congruent to CAD, talking about angles. That's going to be definition of angle bisector. And then lastly, we've got a side angle side, side angle side. So that's going to mean we're going to use SAS. So we're going to fill in our proof like so. And then those would be our 4 answers. So it's 4 points. If you get 3 out of 4 correct, you get 3 out of 4 points. So it's not like it's all or nothing. So you can get definitely, I'm hoping we all get the first one right. is what's going to be the first one in all three proofs? Given. So you get 1 point for sure, and then the rest of them are you're filling in with the correct properties. Any questions that you have for me on that proof? Anything about the quiz tomorrow that you guys have concerns about? All right. The rest of today then is